I always think about multiplayer game development as the holy grail. Multiplayer is the way to develop a game, and single player is a subset of that.
And this is a conversation with Erick Passos, a developer at Photon, a company that creates online multiplayer solutions for video games.
Most basic is you have a transport layer. Second level would be object synchronization libraries. At the highest level for me, it is SDKs that really tell you how to develop games. You have products on all three levels.
Their tech powers a variety of titles, both big and small, such as Peak, Repo, Content Warning, Windblown, Stumble Guys, Phantasmophobia, and more.
There is no silver bullet. People normally come in as, oh, I have this game, I want to add multiplayer to it. Although possible, this is rarely the right way to do. You design the game as multiplayer, and single player is a byproduct.
Online multiplayer has always been one of the most requested features in my own games. So this is part of my personal research journey. It's time to finally wrap my head around this online multiplayer thing.
So you need to have a single source of timing, otherwise clocks will drift.
I found the conversation extremely insightful, and I hope you do as well.
What I'm talking about here is not the common thing people talk about when they develop multiplayer. They think about, oh, I need to synchronize my objects. I need to spawn and synchronize as well. For me, this is, yeah, that's the basic. I like to think about multiplayer in three different levels multiplayer SDK or tooling development. It doesn't matter if it is a commercial tool like the stuff we do, if it is you're doing in-house for your studio, a custom one that works really well for the type of game you're building, or it's agnostic to that. I think about it all in three different levels. Most basic is you have a transport layer that can send byte arrays, can send bytes between machines, either a client server, relay, it doesn't really matter. It's a transport layer. You send data, have a way to send messages that can either be reliable, but without guarantee of time, and then unreliable that can be faster, but it's not guaranteed to arrive. So that's the most basic level. Second level would be what people talk about more commonly, which is, I call them object synchronization libraries. So they help you serialize properties on spawn objects based on, I spawn it here, it will spawn there. I spawn on the server, it will spawn on the clients. And if I modify the data in the properties, that's going to be transmitted one way or another. There are more efficient, less efficient ways of doing it. But this is just object synchronization. You have many, many of these libraries. And some of this stuff out of the box on these engines stops there. So if you think about Unreal's Netcode, the Netcode itself just does that. You have in RPCs, right? So RPCs are message passing with a little bit more metadata. They convert, they serialize some types as parameters, and they can match where to call the method. But that's it. It's transport layer level combined with object synchronization. Then, yeah, you have the character controller in Unreal that does client-side prediction, and then you have game ability system, which also does client-side prediction, but they don't talk to each other. They're independent implementations of a client-side prediction, which is something I believe should be done at the Netcode level. But they have a legacy. They have something that works that's done that way. I'm not criticizing it. I'm just saying that it is an object synchronization layer if you think about the Netcode at the Netcode level itself. Unity's Netcode for game objects is that as well. So it synchronizes objects, but it doesn't really go too deep into the concept of time and so on. Then at the highest level for me, it is SDKs that really tell you how to develop games. Because I always think about multiplayer game development as the holy grail. Multiplayer is the way to develop a game, and single player is a subset of that. So people normally come and ask, oh, I have this game, I want to add multiplayer to it. Although possible, this is rarely the right way to do. The right way is you design the game as multiplayer, and single player is a byproduct.
Mm-hmm.
Because if you solve multiplayer, single player is solved on the technical level as well. And some tooling that you do for multiplayer is also useful in single player, like replays and things like that. This last level is SDKs that actually solve the concept of time and accurate presentation of the objects and the game state in general. Solve this at the Netcode level. And inevitably, the influence on the way you have to develop the game, you essentially have to develop the game already thinking on the APIs of these SDKs. And we have products on all three levels. So if you think about Photon Real Time is on the most basic level. If you think about our legacy library like Pun, which is our most famous product, it is on the second level. It's an object synchronization library that's client authoritative. But then if you think about Quantum and Fusion, they are on the third level. And there are other people doing that kind of thing, especially in-house stuff. Riot uses Unreal for Valorant, but they built their own netcode for that. Or if you think about Valve on Counter-Strike, so this is top-notch stuff, and they use this. They do it this way. So they solve the concept of time. They do all that, or if you think about games like Brawlhalla or even Rocket League, they all had to go down to this type of problem to solve. Some of them solved it in a specific way for one game or one genre category. Some went a little bit beyond, but that's where we try to position ourselves, is solving this type of problem at the netcode level, because I think this helps a lot the developer. They can focus on gameplay and on the challenges that are there, instead of bumping their heads into these problems that are reusable. You can solve them for multiple different games. Because you asked the original question, how complex it is multiplayer. Because it is complex on the technical level, like we've been discussing here, but it is also complex on the game design. If you're going to do a multiplayer game now, you're going to see all of the different things. Okay, what happens if the other guy's a troll? What happens if you have 3-4 players? How do you balance that? How do you think about different roles for the players that they like to assume? Our goal is always to try to solve the technical challenges and help you focus on the game design challenges and the stuff that really makes the game fun.
What you described with the 3 layers. So would you, for example, say that the Steam relay servers are sort of the bottom layers? Like, how did you call it again? How was the first layer called?
Layer. It's a
transport layer. Exactly.
Yeah, it is exactly a transport layer. And Steam is specifically, it's even more restrictive because it is specific to Steam. If you're releasing the game only on Steam, yeah, fine. But what if your game is successful? Now you want to have it on Switch, you want to have it on Xbox. It doesn't work. Steam can only be used on Steam. And yeah, you would have to rewrite everything and make sure. And even if you say, okay, I'll leave it like that, my port for Switch is going to use something else, then you don't have crossplay. We have 2 main products that implement multiplayer in 2 different, philosophically different ways. And there is some intersection on the type of stuff that they are good at that you could do with either. But in general, there is an envelope for one of the SDKs of the type of games that work better, and then other types of games would work better with the other approach, which is more similar to what other tools do as well. Yeah. We don't believe that there is a single solution. So if Unreal Netcode only has one option and one way of doing things, so whenever people are doing something that doesn't fit that, they end up building custom stuff in-house because that would not work. So we try to cover a bit more. We do not solve everything. So there are some genres that if you come and ask us, no, maybe you get a transport layer, it could be ours. And you would need to implement this and that's on top. But we try to cover the most popular and challenging things. That's what we try.
Got it. So the game needs to match the tech, or the tech needs to match the game that you want to make?
Or you design a game around the right envelope of a certain tech. Right. That's another way of thinking about it. Because it's better. You are always designing based on the envelope of the media you were designing for. You were designing for a screen. You were designing for a certain hardware that is capable of some type of presentation. You were designing for a certain type of controller of some type of input. So you always have envelope restrictions on what you're doing. So the netcode is another one of them that you can think about. Point is, if you think about quantum, which is something you mentioned you were interested in another video of yours, it does have an envelope where it shines, where it's really unmatched in terms of what you can get out of it, but it doesn't solve everything. If you try to do some things with it, it would just not work. It would not be the right solution for you. And we're the first ones to say I mentioned this to you when we were discussing before. That when people come asking us questions many times, the first thing we do is ask back, what is that you're trying to build? What is the type of game? Can you describe it a bit, the mechanics? Are there similar games in terms of what you're trying to build? Even if you're not cloning this, but can you give us a couple of references of the type of stuff you're building? And based on that is that we then start giving suggestions and recommendations. Probably you should use this and that. That's an option. So here there are these couple of samples, or maybe when it's a very, very interesting thing, sometimes we even say, let's prototype something together for you. And we may help with that. It's rare that we do that, but we do sometimes. I personally love to work on prototypes. So
yeah, prototyping is fun. We love the prototyping phase.
It's the fun part.
Let's maybe work our way up this pyramid, the 3 layers. And I guess can you come up with any examples for games where maybe it would make sense to start with that very bottom layer with just the transport layer? Or should you almost for any game start with something higher? Or in which cases should you build your own stuff from the transport?
For me, you should always start from the top.
Okay.
The only reason for you to start from the bottom is, there are some cases where you need to have multiple layers at the same time. So I can think, for example, of an MMO.
Mm-hmm.
People many times ask, I want to build an MMO, or should I build an MMO? Was this your last video?
Yeah, that was the last video. Yeah.
And the thing is, first, let's define what an MMO is, because there are different types of MMO. So you mentioned Tibia, which is a very interesting game and so on. But some people mention as MMO a client-server game that runs up to 200 or 100 players on one instance. An MMO is normally a bit more, in my definition, is a bit more than that. You have to have a more seamless, big world where you don't notice that you're going from shard to shard. You are moving from instance to instance, but you try to make that a little bit more seamless. But point is that many people have been trying to build MMO tech that solves all the problems of MMOs in one shot. But if you go look at really how MMOs are made, they need different solutions. So sometimes you use one paradigm, let's say for the overworld. Maybe what you do for the overworld is you use client-side authority for the movement. You have a very, very lightweight thing running on a server that validates just that you don't teleport or something like that, but it lets you pretty much move around freely on the clients, and you're just updating your positions here and there. And you're chatting with people, and you're inviting them for some raids or some instances. Then what do you run on a raid or on an instance that is a PvP instance? Then you can use a different paradigm. Maybe you use determinism. Maybe you use a more isolated client server that runs full server authority for some stuff. So sometimes you just need a transport layer to do chats or some other things around. So an MMO becomes such a behemoth that you're going to use all different layers in one shot. But when should you just use a transport layer? When you're doing something so special, so different, that there is no off-the-shelf full solution on the different layers. One thing I like about our tech is that even when you're using a transport layer, it is a little bit different than the others in that because it's always relayed, there is always our cloud on the back. It's not like a dumb relay. It allows you actually to write custom code to run on our server if your game grows big enough. And this is true for every single one of the tech stacks. So even if you're doing quantum, maybe you've seen that it's deterministic, it's cheat proof in that people cannot modify the game state. They're just drifting their simulation. They cannot influence the other. So you cannot move faster on the other player's machine or something like that. And together with the webhooks we have, you can validate loadouts and a bunch of stuff. You can put the replays. But you can also run the full simulation on our server because the simulation is agnostic to Unity. You can do that. But even Photon Real-Time, which is the transport layer, allows you to write code to run on the server. So, and this is kind of unique because if you go to Steam Relay, there is no option for you to upload code to run on their servers. No. Unity Relay? No. Epic? No. So we're pretty much unique in that even if you're using the transport layer, it always allows you to. But lightweight code on our server that intercepts every single message that's going between the clients. You can block, you can protect, you can do state authority stuff there, you can validate, you can do whatever you want. So when you're doing something that is so custom that does not work with any offering from us or from other people, many times it is interesting to take a look at our transport layer level and build something on top. We rarely recommend that because it's very rare that you have something very, very custom. But if it happens, it happens. Some people built MMO tech on top of our base stuff, but they went a little bit beyond that they don't use the concept of sessions rooms that we offer in our cloud. They actually very early they got to develop with our Photon server, but a totally different application on top of it, and they built an MMO on top of it, which is Albion Online. So it's a successful MMO that's been running for, I don't know, a decade or so, maybe more.
Yeah, I've heard of
that uses our transport layer and our server tech in a different way.
Awesome, I see. And then the first product basically that you built on top of that was a second layer product, which is just object synchronization. And I guess the idea of object synchronization is sort of, right, every player has their own little chessboard and you go on a phone call and I'm like, I'm moving my piece to E4, and then the other one just does that as well as soon as they get the memo.
It is practical. It's easy to use and it works. And it's incredibly successful. I'll list a few games for you and you recognize. So, but a little bit of history here. So Photon Exit Games as a company started in 2003, and this transport layer tech with the Photon Server Cloud, I think it was from around 2010, 2011. And that's when Unity was becoming extremely popular because they released their Windows version of the editor. And they had a RecNet-based client authoritative API called Unity Networking, which was an object synchronization layer built on top of RecNet. But it rarely worked because they were expecting you to be able to just, without doing a proper net punch through, it was actually net punch, but they didn't have a relay fallback, and it would fail 20% of the time, and then people would just not be able to play. So it was not reliable. So back then we built a similar API always on top of our relay and allowing you to write server code, and that became PUN, Photon Unity Networking. And that's our most famous product, the product we're mostly known for, which is an object synchronization layer that's extremely convenient and has been extremely successful. It is simple, it is client authoritative, so it's not super cheat proof in that sense because it's client authoritative by design, right? We've moved beyond that many years ago when we started offering Photon Bolt back then and Quantum, and then Fusion to replace Bolt and PUN in one single SDK. But PUN is still super popular and people still build super successful games with it. Let me list a few for you. Peak. Peak by Landfall that uses PUN.
Oh, okay. Crazy.
Then you have Ripple. Phasmophobia. It works for these guys, and
people
then
like it because it's so simple to implement.
And there's so many tutorials about it. But I mean, I would strongly recommend you to go to the higher level because it is so much easier and it protects you from cheating. It does all this stuff that people complain about, older generation stuff. It's solved on the new stuff. Timing is solved. Cheating is solved with the exception of stuff you cannot really solve at the netcode level, like aimbots. That you cannot solve on netcode, you solve differently. Let me mention some successful games built with newer tech. So Gorilla Tag VR, incredibly successful. That's Fusion. That uses Photon Fusion. Then you have Quantum, Stumble Guys.
Which is massive.
Massive. Which is a game I built the prototype for 5 years ago or so.
Oh, that's cool. Awesome.
33 Immortals by Thunder Lotus, which is in Game Pass, which is a pretty interesting 33-player game, a little bit like Hades, but I'm sorry about my comparisons and descriptions. I'm really a tools developer. I'm not really a game designer.
No, but I've seen that game as well. Actually, it looked really cool.
Wind Blown by Motion Twin. That's also Quantum. It's super
awesome.
Fast. That's a super fast, quick, twitchy
Wind Blown
gameplay.
Is Quantum.
That's Quantum.
It played really well. We played it a while ago and we were like, oh my god, this feels so responsive and juicy.
That's quantum.
Yeah.
There is a story we wrote with them. It's on our blog. I'll send you later the blog post about that. That they describe how they used quantum. They had some pretty interesting uses for replays in development that we didn't thought about before. I forgot here, but I'm gonna send you later.
Okay.
So you have a look at it. So there is another one called so maybe you know Moon Studios by Ori and the Will of the Wisps, Ori and the Blind Forest. So they have this new game called No Rest for the Wicked, which is a top-down. They're pitching it as an action RPG, but it's a mix between a RPG and Souls-like game. That's also quantum, and they're about to release the co-op in the next few months. And I guess that's going to be very interesting to see player reactions, because you played Windblown, right? So, and you say, oh, this is juicy, this feels good, and all that. So imagine that kind of accuracy and twitchiness on a Souls-like game where you have to plan your dodges and your attacks, and you have friendly fire and all that. So that's No Rest for the Wicked. And it's a gorgeous game. So that's also quantum. So there are many things being done in quantum, a lot in the mobile space. There is an interesting tower defense from Korea. I think it's called I forgot the name of it. Anyway, it's not relevant. But there are many people who found out about quantum, especially after we released it as a free to use SDK, and there is
let's get into it. So your two flagship products at the moment are Quantum and Fusion. Can you quickly describe sort of the philosophy of each and what their strengths and weaknesses are?
So there are basically two ways of developing multiplayer, which is, if we go back to the beginning of our chat here, the challenge is you have multiple devices, multiple computers, and the game's running on them. So the actual goal is to make sure the game state is synchronized, is that you have the same game state at all times without too much latency in when things change. That's the goal. There are two main ways of doing that. So you either keep transferring the state changes themselves. The other option is to, if you have a deterministic simulation, if you are capable of implementing a deterministic simulation, you can transfer just the input. That's incredibly hard because you cannot use floats anymore. You cannot use Unity as the game engine because Unity is not deterministic. You have to have your gameplay layer, and that's what we ended up with, a solution for that. But the point is, these are the fundamental ways. Within the state replication variation, in which you transfer state, there are two main sub-variations. One is that when you have a single source of authority, a server, and you have client-server model, in which clients only send player intentions, input, and the server is responsible for actually changing the state and transferring back to the clients. Clients can still do prediction of changes, but the server is ultimately responsible for the final variation of it. Or you can have distributed authority or client authority, in which each client is responsible for changing the state of some of the objects in the world, not all of them. So you can have some mixed variations, but these are the fundamental two ways of representing state. And then there is determinism, which is another way. So we have Fusion covering the state replication. So it has client-server model, pure client-server model with server authority, both for you to run as a dedicated server, a Unity headless instances dedicated server, or as one of the players being the server with a net punch and a relay as a fallback with a host migration and all that. But programming-wise, it is the same as dedicated server model, just that the server also has a player and a rendering layer. And there is this what we call shared mode, which is the client authoritative variation of Fusion that uses the same APIs with a couple of exceptions that are not available. So you don't use the input loop because there is no need for it. But otherwise, the API is the same. And then you have Quantum implementing deterministic predict rollback on this other side. So with this, we cover most of the different types of genres. What do you use them for? What kind of stuff? I mean, if you're doing a shooter, we're normally going for client-server with client-side prediction and lag compensation. That's the stuff we have built into Fusion. There is a reason for that. Everything that we do in Fusion in terms of client-side prediction, actually Quantum does even easier and better client-side prediction than Fusion, because Fusion for physics prediction, for example, is limited by physics. that cannot roll back on Unity. Quantum is not, because we use our own physics engine that's designed for that. But we have lag compensation. We also have a sample for lag compensation in Quantum. We can do the same, but there is a big reason for you to use client-server model in a shooter, because when you use determinism, it's cheat-proof in terms of people cannot modify the game state at will, but they can see it. So every single client has the full game state. So what we call map hacks, which is if you scope into memory, you may be able to see data about the entities that maybe you don't want to show to every single player. So in a shooter, that's very, very sensitive. I mean, it's still a problem even in client server when you have somebody behind a wall, because you already have the information about that guy on the client anyway. Otherwise, you would not have it when he runs out. So people can still do aimbotting with that, even on client server, but at least you don't know where everybody around the map is. Unless you see, because state synchronization can have what we call interest management. And of course, Fusion implements that. Based on area of interest or custom options, this player should have access to this object or not. So you can set that kind of stuff. So if you're doing a shooter, normally you go for that. And
if you want to do a server authoritative, do you have to write a separate program for the server probably, right?
No, in client server mode, what I'm talking about is that is the same code that you write that runs on the client, runs on the server. You can if-def stuff, so you can have stuff that runs only on the server if you want to, but you are writing your server in Unity as well.
Okay.
What I mentioned before, that even in shared mode, which is the client authoritative version, the advantage we have is that even though it is client authoritative, it's not a dumb relay. It's not that our cloud is just passing data around. It actually keeps a copy of the game state. So you can write server code to intercept and validate and modify the changes. But that is on the client authoritative variation. It's a lot to grasp, right? So
So I guess to break it down a bit, there's Fusion and there's Quantum, and both of these are each available in server authoritative or basically not, just relay versions, right?
No. Let me try again here. Client server is one way of doing netcode. It's one way of doing netcode. Fusion implements that mode. By client server here, I mean there is a server running the same game engine as the client, but it is the only one responsible for changing the data on the objects. Clients cannot change the objects. That is one way of doing multiplayer. Determinism, which is what Quantum does, it's a totally different way. You don't need a server to have the game state at all, because the only thing you're exchanging is input. There is still one server, but it's to coordinate timing, input stream, validate some other stuff, but it's not running the simulation.
Right. But I guess for Quantum, the question I have more is like, if you want to make something highly competitive, then you probably still need a server to verify game results at some point, right?
Excellent question. We have an entry in the docs exactly for that. But server, is it safe? Yes, absolutely. But it is also expensive. So Quantum is interesting because when you use determinism, without the server, without the validation of the game results, you're already protected against a lot of annoying stuff. So people cannot ruin the game experience of others, like by teleporting, moving faster, because they cannot really control the simulation. They can only send their player intention. Let's say, oh, I want to move in this direction. I'm moving in this direction. They cannot really say, I'm moving faster, unless you make a mistake in your programming model. But as long as you follow the examples, you just understand the basic concept, you're sending just intention. I want to do this. Who says you can do that or not? Your simulation implementation that's running for everybody. So if I'm not a cheater, nobody can cheat the game state that's running on my machine. They can only send their intentions. I call it simulation authority in that sense. That's the first layer of protection you have. Second one is that we also have hooked in the base model webhooks. So we have webhooks for you to validate the game loadout. We call it runtime config, which says, let's say it has your game mode or something like that, or the player loadouts, which is I join the game, I want to add a player that's going to spawn my entity or something like that. You can validate the loadout with your choices. I want to play with this character. You can validate that with your backend. So we have webhooks for that. This is a second level of protection. And these webhooks can also let you upload the replays to your backend, the full game replays. And that means You can also store the replays from the clients for convenience for the players to watch or whatever reason you want. But having the replay is interesting because if you have a discrepancy in the game results, you can use your backup replays to retrofit to post-fact validate matches where you had non-matching results. So 90% of your matches, 95% in our experience, 99.5% of the matches are not going to have anybody trying to do anything, and they will have matching results anyway.
Yeah.
Unless you have a bug in your implementation that is non-deterministic, but we have tools to help you with that with checksumming and frame dumps and all that. But those that don't match, first level is like you have a replay. I mean, second level, you're already validating loadouts. Second extra level is like, okay, replay validation. Third thing you can move towards is, okay, I can run a concurrent spectator that goes into live games, let's say important games, like if you're doing a tournament, a ranked mode, you don't have to go into every game, but you can statistically validate some matches with a live client that does not even run Unity. It's just spectating the game and running the same simulation, and you trust this machine because it's running on an Azure instance, whatever. You trust this guy to push the game result. You can also do statistic validation with replays, and that also helps. But then the ultimate level is, yes, you can, if you grow big enough, you can run dedicated machines with this on our clouds, and you can load your simulation layer, which is not Unity. You do not need a Unity license for that running on the server. It's our stuff only. And we can run hundreds of these in one bare metal machine. So cost-wise, it's still super effective. And you are, in that case, yes, you are running the full simulation on the server. The game result can come from our server directly to your backend. So the idea here is that you do not need to go from 0 to 100 in one shot. You develop your game the right way, play test. Does it resonate with players? Yes. Okay. You go to the next step. You release the game. Does the game sell? Are people like it? Are the reviews good? Yes, you continue. If not, you didn't have to spend stuff up front with servers or anything. You're just testing it out. You use the free 100 CCU layer that you can even run commercially just to test things out. You don't have to compromise anything. You become successful. Then, okay, am I having a problem? No, fine. Oh yeah, there's some problem. Let's start with replays. Let's start validating stuff. Let's find out who is cheating. Because here's the thing. You validate based on replays when things don't match or when you find strange results on your player backend, and you caught the guys who are doing nasty things. You ban, you apply a penalty. They're going to stop doing because they know you find out. Unless they're just annoying. And then you go for the next level. But remember, the annoying parts will not affect the other players. They're just... So I like this fact that you have this more gradual approach to adding validation layers. You don't have to upfront compromise. This saves you time. This saves you development effort, which is time.
You're very much right in that is extremely important for indie game developers. We don't know upfront if our games are going to be successful or not.
Yeah.
Yeah.
So that's why I like determinism as an approach so much, because it allows this kind of, if you have a tool to do that, we're still kind of alone in this. There is people doing this in-house. I believe Brawlhalla is a bit similar to that, but I've never had a chance to meet the team. It's an awesome game. I believe they have something like that internally, I would say. But yeah, when you have this kind of thing and you know how to use, it is really, really powerful.
I'm not sure if you saw the podcast I did with Johan Grönwald. He's the developer of Bopple Battle, which is like an online multiplayer party game. And he actually wrote his own deterministic simulation. And I was quite impressed by that. But I think one thing that differentiates your product even further is all of the client-side prediction and rollback stuff, right? Which is, I think that part is very tricky to do if you want to do it yourself. Or what's your estimate on that?
I mean, it's, in one way, it is simple, but again, it is it's built layer by layer, right? I really admire these guys that built a specialized solution, because if you see how much there is in the stuff we build, you think, how can you do that alone? The point is that you cannot. But we're building for multiple different genres, for multiple type of games, and for people who are coming to it without knowing how to do this. If you know how and you do specialize, I still admire, because it's still a lot of work. But you start with the principle that, so I'll give you an example. So the timing stuff I talked about, and the fact that we always use a server to be the distributor of input and timing. Why do we need that? Because our product must do more than 2 players. If you're doing only 2 players, you can actually synchronize the clocks with just the 2 of them. But you still have something called rifting that GGPO style stuff has. That's what we don't suffer from, because this problem only exists because you don't have a synchronized clock. But if you're trying to do 3 or more players, you need a central source of the inputs, streaming, and everything else. Otherwise, it's impossible to solve, more or less. Yeah, you will fail in some edge cases. With a server, you'll never fail in edge cases. We do up to 128. But if you're doing something more simple, you can go away. You can go around some of the complexities. Then it all depends on how many things you want to get out of the box from an SDK or from an internal tool. So we have 2 physics engine, a 2D and a 3D physics engine, fully fledged with a continuous collision detection, shapecasts, stable solver. It's a lot of code just to get that running. And you have the 2.5D and the 3D ones, they are independent. We have fully deterministic NavMesh, we have flow fields, we have a fully fledged AI SDK for you to build behavior trees, hierarchical finite state machines visually with a visual editor, with visual debugging, so it's layer on top of layer on top of layer, because you're building for multiple different developers doing different things. If you're doing something specialized, it's a lot less code. So, but the predict rollback, which was your question, it is built in the basic core. So the basic core contains the concept of a game state that we are constantly rolling copy. What we do is we get confirmed inputs, we simulate forward with confirmed inputs, then we copy that into a clone version of the game state, and that one is predicted forward. Then no input came, we just continue predicting a bit more. Oh, new inputs, simulate these guys, copy from again, resimulate the prediction. There are some variations we can do with intercalating between moving the verified, moving only the predicted, and to organize CPU consumption. There are some options that you can, advanced options you can use, but it's the basic principle to it that is constantly being done. So the fundamental ability to be able to copy the full game state very, very fast is one of the key aspects of it. If you cannot do that fast enough, you cannot do predict rollback. You have to be able to copy from, to do mem copy of the whole game state, physics, whatever it is. So we designed the whole API, the whole ECS, the whole game state on top of this approach.
But in quantum, it's basically, I think it's called ring memory in the API a couple of times, right? Where you have a bunch of ring buffer, and you have a set amount of frames that you can store.
We don't do that anymore. We only have that in Quantum 1. Yeah. We don't keep a ring buffer of all the frames anymore, because that's more expensive, both in memory and in mem copy. And I'll explain you where that comes from, where people think that's a good idea, but it's not. The thing with the ring buffer is that, you can always not roll back. You don't need to roll back if the input is confirmed. So if you have the full ring buffer of the predicted inputs, and you then get 2 new frames of inputs confirmed from the server, if the predicted inputs you used match what the server confirmed, and the basic principle is that the heuristic tries to copy the input from the previous frame for all players, and for the local player, we're actually using the poll input. So if it matches, you don't need to roll back. I just move a cursor that the verified frame is now here, and I continue. That's a bad idea. It sounds like a good idea, but it is not. 3 reasons. Number 1, in practice, this rarely happens, because in practice, small mispredictions are actually called by the input varies. Especially as you move towards 10, 20, 30 players, it's guaranteed that somebody's changing a bit of the input during one frame.
Yep.
So you will always be rolling back anyway. And why is that important? Because you have to prepare for the worst case. If you think about your delta snapshot, your delta time thing. What we're fighting as game developers is not frame rate. I hate frame rate as a measure of performance. I mean, if we're doing free frame rate, fine. But you say, oh, instead of running at 60, I was running at 48. No, you were not running at 48. You were running at 60, but you had 12 frame skips, which is your scripts didn't finish in time for you to be able to push one new render frame to the GPU, and then you got a frame skip, and then you had that 12 times over the course of a second. That's what happened. So 45 is worse than 60, but for me, 59 is equally as bad as 48. You want locked 60. So because you don't want to have a single frame skip. What does this have to do with what we were talking about? You do not want to have, let's say, one update where you don't have to roll back. That is cheap in terms of CPU. And then one time you come and you have to roll back and you have a very expensive rollback and prediction. That creates fluctuations in how long your simulation takes. What you want to have is a very predictable, pun intended here, double pun intended because of our product name. But you want to have a very reliable or stable time for the simulation to take. So what you want is to actually constantly roll back and make sure that your simulation never exceeds the ceiling you want it to be at. So don't get fooled by not rolling back. That's not really relevant. What you want to do is you want to make sure your prediction is lighter weight. That's why we have prediction culling features built in. Because you want to make sure that your prediction is as light as possible, and the verified frames are the expensive ones where you run more complex stuff in, and these running at a steady pace constantly. That's much better than having a fluctuation in simulation time that just causes frame skips when you have rollbacks. Because it's very easy to develop thinking about, in my tests here, rollbacks are not happening. And then you start getting spoiled, you add more complexity to your game, and it never hits the ceiling. And then when you test with players, bang, all of a sudden your frame rate is at 45. You don't want that. You want to know exactly how it would behave. That's one reason. That's the one I like to talk about the most. But at the same time, a ring buffer takes a lot more memory because you need to take into account that you may be predicting half a second in ping spikes and in highly lost conditions. So at 60 hertz, that's 30 copies of the frame. In reality, we only keep 4 copies now, constant 4 copies. So the amount of memory we use is fixed. Second thing is, when you do a ring buffer, if you have to do a 10-tick prediction, so you roll back, simulate forward the verified frame, then you have to do copy from, which is a mem copy, and then for every new frame, you have to copy from. So the amount of times you call mem copy, you call copy from, becomes proportional to your ping. And you don't want that because that's instability again. So because the bigger your game state becomes, the more expensive the frame copy becomes. As efficient as it is, at some point you get it to 2 megabytes or something like that, or maybe more. So what you want to have is you want to have a constant time for that. So that's why we only have 4 frame copies. We have a verified copy. We have 2 predicted copies for interpolation, and we have 1 extra copy for error correction. For view misprediction error correction, to smooth out prediction errors. And you can actually disable these copies and do them yourself, so we only do 1 copy from verified to prediction. So we have a constant amount of copies every time there's a rollback. It never goes, it doesn't matter if we're predicting 30 ticks, 3 copies. So it helps you control the time. This is the kind of stuff we're also trying to improve for the next versions of the SDK. We're constantly getting to the edge. We're introducing a new ECS model now. We're trying to work on a copy on the write heap. So even these mem copies are going to be cheaper, even these 3. We're trying not to copy the full game state on the 2 extra copies. We'll copy only the full game state for the predicted frame, but for the ones that are used only for view interpolation, we're going to copy only the transform buffers, not the full frame, because we don't need to. So we're constantly optimizing stuff, but no ring buffer.
Okay, so the ring buffer has already been optimized away, essentially.
Years ago, we abandoned the ring buffer idea.
Okay,
It was the way Quantum One used the ring buffer. I think it's the way GPO works. That works on tiny game states. If you're doing a fighting game, it may work, but you don't gain anything from it.
Okay,
This other model is better in every single aspect.
Cool. So you can now develop the game and simulate a couple of rollbacks maybe so that you can get realistic performance in editor and don't have any unpleasant surprises.
You can always test online. You can induce anything you want. You can introduce loss. You can introduce and test. And we encourage people to do it, right? So to test all the time. We try to build tooling around that. There are people who really get it, and in our public Discord, like indie guys just doing some free games and some stuff, so that really get it, and they would advocate and they would help a lot. So there is an interesting community being built around it. I really like to go there and chat a bit sometimes.
Is there any reason to use Fusion over Quantum except for hidden information that you might not want the client to have access to?
There are. I mean, Quantum has, you said this yourself, has somehow a steeper learning curve. So it's a little bit harder to get at the beginning, although we tend to see that once you get it, you just think on gameplay and you flow, you go much faster in game development in general. But Fusion is much easier to start with. You use a lot more Unity stuff. So this, let's see, a more practical stuff. You have an asset from the asset store that does AI or something like that. Forget it. You're not gonna use that in Quantum. It's not deterministic. It's not built. Quantum is the game engine. Unity becomes a passive presentation layer. So yeah, I love Quantum. It's an amazing tool. I helped build it, but if you're coming from a Unity perspective and you have a lot of assets you like, that's why we have to build these things like our AI SDK, our flow field implementation. Some of them end up being better than anything you find somewhere. Some are not necessarily. So, for example, I'm responsible for building vehicle physics stuff. It's something I love to do. I have a ton of experience doing this, but I love some of the Unity asset store stuff. So I specifically like Eddie's vehicle physics. I know him personally. We worked with him to help us build our own. So he helped us understand the most important aspects of that, and I learned a lot from him. But his stuff, I mean, Eddie's Vehicle Physics Pro is a great tool. So if you're using that on Unity, that's ultra easy to integrate into Fusion, especially Fusion shared mode with the new forecast prediction model. We call it for PhysX, that doesn't do rollbacks for fixing predictions. It's super easy to integrate that into Fusion. Whereas in Quantum, you have to not use it. You would have to use my vehicle physics. I'm proud of it, but it is a different one. You have to learn it. You're not going to be able to use your favorite tool. You can use anything visual, any shader, any models, animation, tooling. I mean, you can use any Mancer. You can use Rewired for input mapping. You can use any of that. But code, gameplay code, assets, forget it. You're not going to be able to use them in Quantum. Whereas in Fusion, you can. So especially in shared mode. This is an interesting thing that, for me, it is still more important to use the tool that is more suited for the gameplay you're doing, because this, at the same time, this can be an advantage to some teams to reuse some stuff they already have, but it can also be a trap. So that's why I like to think each case is a case, and you should always carefully consider, do not be afraid to learn something else. Everybody who really learned Quantum, they don't look back. They really like. And most people at the end get that, yeah, there are use cases for this and for that. You should always use the right tool for the right job. It's also easier. This is another controversial one. Especially Fusion shared mode, the client authoritative version, is the closest thing you would get from, I have my game, I want to add multiplayer to it. It's not a click this button to add multiplayer, but it allows you to try to do it one step at a time. It's more friendly to that. Again, it's controversial because I'm not recommending that this is the right way to do your multiplayer game, but sometimes it is the only possible way. It's an existing code base that you already released. Although we have cases of people who rewrote the whole thing in Quantum to get the advantages of it with a released game. I know at least 2 or 3 cases that did that successfully. But yeah.
In terms of performance, are there differences? Because I think in Quantum, you have to be a bit careful with performance so that you can essentially simulate multiple frames in one frame so that you can do rollback, right?
You are always rolling back, although that's the less... I mean, you can... When you get to that, you can control... So think about Unity's fixed update, right? So fixed update can happen multiple times. It depends on how your rendering time is. So So think about Unity's fixed update that runs at 50 hertz, 50 frames per second by default. You can change that, but default is 50. If you're rendering at 30 in a mobile phone, whatever, WebGL or something, your fixed updates on Unity, including PhysX, sometimes you're going to have 2 calls, sometimes you're going to have 1, sometimes you're going to have 0. Most probably never 0, but it can happen. You can have aliasing and not have a single call of that. Oh no, not at 30 hertz, but at 60, yes. Quantum's verified frame is basically the same. So because they only move forward. For example, you can put 50 hertz in Quantum. It's going to work as smooth as anything because the view is interpolated. So say you use 50, same as Unity. Quantum's verified frames in an online game are only going to move forward, and they're going to behave very similar to Unity's fixed update. And you can even clamp. We even recommend you to clamp that to 3. It's not a setting, but it's something you can procedurally set into the session object. You say, I want to clamp to 3. So you never exceed 3 verified frames in one Unity update. And 2 is a little bit dangerous to death spiral if you go behind a bit, but 3 is safe. So you can make sure it never goes above 3. But then you have the prediction. But the key for the prediction is to make sure your prediction frames are ultra cheap. How do you do that? You have multiple techniques you can use. The basic stuff is just set a prediction area to what you see. If your game is a little bit bigger and there is stuff you're not seeing, you set the prediction area, or you use a custom frustum culling based prediction, which is on our docs how to do. You can make sure that you only simulate the entities that are in view for prediction. Verified, you always simulate everything, but that behaves like Unity fixed update. So it is the problem becomes, can I run the complexity of this game in a single machine? Well, if you go server, you'll have to run it on the server. But the point is that my target devices like Steam Deck or something like that, are they capable of running this game forward at this step with all the complexity I put into the game? If the answer is yes, then there is a way to make sure that the online variation runs as performant. It's just, so you design carefully. There is an envelope for it. It's not, you do not, if it's something that it does not fit, then you should use something else. But the point is that if it fits, if you can run it forward, it can run online. One interesting example for stuff not to run in prediction. So when you're running AI and bots, which is complexity of multiplayer game development. Single player, you design boss encounters very specifically and all that, and you can make AI dumb because it's just AI for you to beat them up and easily and have fun doing it. Today, games are as easier and easier with some exceptions like Metroidvanias and this kind of stuff, but all Souls-like. But when you do multiplayer, one added complexity for you as a programmer is that you have to write bots. Because you say, no, bots are not fun to play. It's fun to play with other players. Yeah, when you get to a certain level, when you get to the competitive level where it's only fun to play with other players. But you always want the first time players play to be with bots, so to make sure they beat the bots. Maybe you want to pair a couple of players in the same, if it's a team-based thing, you put real players in the team against bots. Then on the second match, you put these second round players to play together, you match levels of them, but you always have to have bots. It's very rare that you're going to have everybody filling games to fill a 4v4 game in matchmaking is incredibly complex. You have to have so many players playing at the same time to always feel 10-minute matches with 8 players each. People don't make the math. So if your game lasts for 10 minutes and you need 8 players in each game, the other variable is how long do you want people to wait in matchmaking. So if you put 30 seconds, which is half a minute, which is a very long time, but let's say 30 seconds, it means that within 10 minutes, you have to fill in 8-player games 20 times every 10 minutes. So you need to have 20 times 8 every minute coming into the game. How many players is that in total? Is
160
in one region, just to have an 8-player game. So if you want to have a 100-player game, that becomes... So you're all...
And that's only if all of the players are at the same skill level, which is also...
that's for each bucket. So if you think about, I want to have 10-second matchmaking time at the beginning so people don't get frustrated. Multiply that by 3 then.
Yep.
So you need to have 500 players at the same time. Do you have any idea how many players you need to have 500 players at the same time? You do, because you have a released Steam game, so you know your CCU numbers versus the number of copies you sold. So you have an idea that it's on launch. This is different because you have a peak, but when it settles, and for multiplayer this is super important, you get a 20-20 relation, which is what I like to call it. It's like for every online player, you need to have 20 times that in daily active and 20 times that in monthly active. So to get 1,000 concurrent players, you need 20,000 daily, which is 500,000 copies sold. That gives you roughly 1,000 concurrent. But so bots are important. Multiplayer. More complexity on your development, because you have to think now about bots playing as a player, not bots as enemies only. So it's not only gameplay anymore. I have to write a bot code. And bots are some of the more expensive code you also write, AI in general. So that's one of the stuff that we always help. Sorry, I always take very long arcs to come back to the original thing. So bots are expensive to run. So I always like to recommend people to, when you're writing bots, make sure your AI has at least 2 different tiers. So you have a decision-making tier that has the expensive stuff, and you are only going to run that on verified frames. So you'd never run that on prediction, because prediction can fluctuate, and you never, even for visible stuff, you don't want to run the planning stuff every time. But the operational tier of the agent, which is the thing that steers the agent, that does the movement, that uses timers to shoot or to follow a character, that one you always run on prediction if the entity is within the visible range, if it has a target, and so on. So you always plan to implement your AI into these different tiers, because you want the visible aspect of it to run in prediction, but you do not want the expensive planning part to run every time. You want to run it verified only, because again, if you can run the game locally forward only, you can run it online with the same performance with the same amount of entities.
Is there built-in functionality in Quantum to run specific code only on verified frames?
Yeah, it's an if away. If f is verified, if frame is predicted. You have that in the frame class. Frame is the game state that you receive from the update methods in systems. You have frame is verified, is predicted.
Okay, and I'm allowed to do checks like if this is a predicted frame, then I just don't run the section of my code, for example.
Yes. Just early exit on the update.
Okay, and this will not cause any desyncs or whatever?
Never, because only verified frames matter for these syncs. Why? Because we always roll back and resimulate. There is no rollback skipping.
Okay. Hey,
ring buffer is a bad idea.
Okay.
You wouldn't have this.
That was one of those really valuable insights, because I don't think I would have figured this out on my own or in the documentation.
I'm telling some secrets.
Yeah. No, this is really good to know. Just don't run the expensive stuff in the prediction frames.
Run on verified, yeah.
Cool.
It is a different... I mean, you have also the prediction culling layer, that if you have a game that spreads around an area, you can afford to run stuff in prediction as well within a certain area. So it really depends. I mean, I rarely think about this in advance, with the exception of the AI. I like to think about the AI that way, but anything else, I don't think about it in advance. I start adding because I know prediction culling is gonna kick in as soon as I enable and so on. So, and again, don't underestimate the performance characteristics. It is damn quick. It is where my rule of thumb is like I always like to run my simulation within less than 2 milliseconds, ideally less than 1 millisecond for the whole simulation, including predict and rollback, for at least for prototypes I write. But I like to get my verified frames even in production to max 0.205 milliseconds worst case, because then my prediction frames are going to be 0.1 or so or less. I'm a performance freak, so
I like that.
There is a video I have. I think I linked it to you before. There is a few chapters on optimization. I explain all these things I talked about here are explained in steps. I mean, how to enable prediction culling, how to run stuff on verified frames, and examples of when that happens. Another cool. I forgot to mention this one. This is also cool. You can do what I call time slicing. So, say you have 100 entities that are enemies that you want to run complex AI decision. You already moved this to run on verified frames only, but still your verified frames are running above 1 millisecond or something. You want to optimize it a bit better. Then you can think, okay, the steering of the AI is already fast enough, but do I really need to run the planning agents every single frame for every single entity? Maybe not. Maybe you want to do, what if I run every fourth frame for each? How do you split the entity so 25, 25, 25? There is an easy way to do with the entity index mod operation with for compared to frame number mod operation for, or update rate you want to. And then you compare, you only update the entities that match. So you're going to have 1/4 of them in one frame, 1/4 on next, and so on and so on. So you time slice the stuff not only to run on verified only, but every fourth verified frame, equally splitting the entities according to in sequence. So you get, again, a constant time that is 4 times smaller, and instead of spikes. Because you can think, I'm going to run this system every fourth frame. That's a bad idea, because you're going to have every fourth frame a spike. What you do is you time slice the entities, having 1/4 of them every frame, and in verified only. So you combine these techniques together. That's the bread and butter for having a very smooth gameplay. Some of these techniques are valid for single player. Unity in general, some time slicing for complex AI on a local RTS game. Do it.
So what if I wanted to make like a strategy game, like for example something like Thronefall or I don't know, StarCraft or Age of Empires or whatever? Is it
No
still
one is
possible?
crazy about strategy games. It's because, well, pretty much every single one of them uses determinism. So you probably know that. But the thing is that what I like about that is the challenge, because RTSs for me are the combination of everything is cutting edge. So if you think about, okay, entity count is at the limit of what you can do. You have tactic formation, which is, so Pathfind is incredibly difficult because you have group formations and all that. And then you have, the economy or the tech trees. And then you have to have AI on every single one of these entities. And you have to also have a layer of an AI for you to play against as a tactical commander of the other army if you want to. You don't want always skirmishes with other players. So everything is cutting edge. And you cannot use state transfer because it is so... Yeah, you can if you optimize like crazy, but honestly, you would be basically spending time on that, and you still have to do the other type of optimizations for everything else anyway. It's so, to me, running state replication in RTSs is an exercise, but it is not really a good solution. Yeah, you don't get map hacks if you do interest management, but it's so much work to do that. Nobody does it, in at least the games I know about, with one exception, which was a special game, Planetary Annihilation, that uses this chrono chem thing that is a special encoding of state. It's not really state in that they send these curves that is a bit like input. It's deterministic, so but they send these curves. So yeah, you use Quantum for that. We used to have an RTS template or sample that in Quantum 2. We didn't port it to the latest Quantum 3, but we did port and improved the flow fields implementation, which is the basis for group navigation. So you want to have 2,000 units, it runs with group formations, reusing patches. It's a not verbatim. It's a by the book implementation from the AI. It's not AI gems. It's the definitive article on flow fields that there is in game AI. We implemented all the techniques in there. It was a friend, a colleague, Thomas, who implemented this, and we kept it maintained, and it is updated to latest version. That you would probably gonna use that for, because if you're doing multiple units, but there are many tricks in RTS, so you can use. So so if you think about StarCraft, my favorite game, Zerglings, they're not really individual units. Visually they are, but entity-wise, you can combine 4 together. You can do do some tricks to get more eye candy without actually going crazy on that. But there are lots of interesting features we have. So you mentioned that we have this thing called prediction culling that allows you don't need to simulate stuff that's not in your camera for prediction. But in an RTS, maybe you don't even need to predict everything. But it's a good. Have you seen this latest RTS by these ex-Blizzard guys who wanted to build some like a spiritual successor to StarCraft? It's these guys that build.
Are you talking about
Frost Giant?
Yeah, of course.
Yeah, Stormgate. So what they have is a mini specialized quantum that they built themselves for 32 players. Yeah, they're doing predict rollback at 60 hertz essentially. With I think last time I talked to them, they didn't have yet prediction culling, but they were talking about it. They had to implement it at some point, I think.
Yeah,
but it's that idea, right? So besides prediction culling, because in an RTS, maybe you don't need to run prediction. You can run basically kind of lockstep verified only, but it's nice to run prediction because you click, you see it moving, right? So and it doesn't hurt. It's so cheap to run prediction on something very close to you. But there is something more interesting, which is how do you prevent all of the game views, the game objects that are around the map? I mean, the game objects, I mean here, you have entity moving on the other side of the map that you don't have to know about. And maybe Quantum is spawning the entity view for that. And because it's in your fog of war, you are going to have to write code to disable that or something like that. We recently introduced, and I implemented that, which is a way for you to cull views by you can overhaul our basic behavior for which entity views need to be instantiated locally. So you don't even have to spawn at all a view for an entity that's out of your scope. This sounds obvious, right? But you could do in previous versions of Quantum, but you would have to re-implement what we call the entity view updater or something like that. Now it is built in that you can, you just implement an interface and then it's very easy for you to decide what to see and what not to see. And then the view is not spawned at all, and then it's something less for you to worry about in terms of scalability of rendering and all that. So you use the fog of war data in your simulation to decide if the local player should have access to it or not, to the view. So you're going to use all these little tricks together to make sure you can run an RTS game. It's still one of the interesting genres that is challenging to do.
For sure. I also think if we were to make an RTS, it wouldn't be a fully fledged one. It would be a somewhat simplified one, maybe a base defense game that plays a bit more like a tower defense or whatever.
Yeah, the game. We have a lot of tower defense games in mobile being done in Quantum, right? So but
that works.
I've seen your games, and that's definitely something I would personally do with Quantum or something similar.
Yeah, makes sense. I see. So it is still possible to run Quantum in Lockstep if you don't want rollback?
In multiple ways, yes. We still have a setting for you to do that. I would personally never use it. I don't see really a reason not to run a prediction, especially because prediction culling allows you to run it so quickly. So if you think about the systems, there is a way for you to not even schedule the system to be on the task graph on predicted frames. We have some base classes for systems that are convenient to use, but if you use the very base system, it has a schedule method that you decide if you want to schedule it or not to go into the task graph or not, and you can decide not to schedule it on predicted frames. So there is no overhead at all. It doesn't even get scheduled. So you only run the stuff that's very local, that's like, okay, the click to start the movement of the things. You only run those things. You don't need to run, for example, progress for units or stuff like that on prediction, but you run just the movement stuff with prediction culling enabled. You run only that. Don't run the pathfinding with flow fields. You only run the initial, because it's going to start moving on the local flow field initially, because you probably already have, you run there is the main A star for the patches that decides the exits between the patches, and then there is the flow field update itself. So if you run you don't need to update the patches because the patches probably already exist, but you just run the main A star, you already know the direction to go to. So that already shows when you click, and it's incredibly cheap to run. So I would not go in Lockstep. Is it possible? Yes. But there are better tricks for that. So Moon Studios, for example, one trick they use is that the worst offender case is when you have a rollback, when you have input confirmed, and you get more than one input tick confirmed. So let's say you received 5 different input ticks from the server in one shot, and you still have to predict. So simulating 5 verified frames plus that, it's too expensive. So, but let's say you were clamping to 3. So, okay, simulate 3 plus 8 predicted. That may be expensive. But there's a trick. You can again use a time slicing strategy, which is Quantum allows you to, when you have multiple frames, verified frames to simulate, you can decide to, I'm going to simulate my verified ones, but I'm not going to roll back the prediction and resimulate from the beginning. I'm going to just do one extra prediction and accept that it is kind of like out of sync with the verification.
Yeah, okay.
And then on the next unit update, that I may not have any verified or maybe 1 or 2 verified, I do the full rollback and resimulate. So you keep intercalating between that. If you just download Quantum and start using it, it would not behave like this, but it allows you with a callback to decide exactly how many verified frames to run, if you want to copy for the prediction to do the full rollback, or just update the prediction and accept a little bit of out of syncness in the visuals. So and that's what a complex game does. So I would use all this before deciding I'm going to run Lockstep, because it's so incredible to have initial feedback.
That's true. I guess there's one case I can come up with where I'm like, I think I really wouldn't need any rollback for this, and that is an auto battler, where basically both players place their units and then they just go up against each other.
That I would not run Lockstep still, but what I would do is I would run everything you were talking about in verified frames only, so they cost nothing on prediction. Prediction is just a empty thing.
Okay.
And I would run the views in snapshot interpolation mode. Because here's one thing. If you run stuff in verified frames only, they're going to be jittery. Just like we discussed at the very beginning of our chat. But Quantum also allows you to have snapshot interpolated views, which are interpolating between previous verified frames. Do I keep a ring buffer for that? No, not frame ring buffer, but the transform, I keep a small ring buffer of the transform data, so we can smoothly move the view here, even though the verified frame is kind of oscillating, the speed at which it updates forward. So just turn on snapshot interpolation on the views for these auto battle units. And yeah, that would be my suggestion. So yes, you don't need prediction on that at all. So run everything on verified frames, but snapshot interpolation, because maybe you want prediction on some other stuff going on, like a card selection or unit placement. You may want to have that with prediction so it reacts immediately. I would, because I would almost never use lockstep mode nowadays.
Mhm.
I will always
Okay, got
find
it.
something where prediction feels better,
Yeah.
even if 90% of the game is going to run verified only, and some snapshot interpolation, I would use that prediction.
I see. So there's not really a good reason to turn it off, because you can always just disable basically a lot of the systems,
Yeah,
and then
and it would cost the same as lockstep, and you get some initial feedback that always feels better. So.
And for an auto battler where there is hidden information for some time, maybe, right? Maybe there's like both players need to pick an upgrade at the same time, or both players need to place units at the same time. What I was thinking is maybe you can do something like make both players send their input at the same time. So the input would be where they placed all of their stuff, like more of an event or something.
That's an interesting thinking. You can do that. So one thing is that you just need to be careful that. So there is one input type in Quantum called command, which is reliable. So they can also be predicted, but they are reliable. So what you can do is, if your game design allows for it, and the player can plan his move, and you can basically even take the frame data as you see, as it is available in your machine, for the player to think about his movement, and you can, let's say, run the pathfinding from the view without modifying the game state, but just, okay, where if I put here, if I use this command, this guy's going to attack that unit, and you can predict how much damage you're going to have just by running the code that would do the damage in trial mode. You can get that code accessible, so the view can run it just for the player to see.
Yeah, I mean, let's for example say with a more simple example. For example, both players get to pick an upgrade at the same time, but it would be bad if you knew what the other person was picking, because then you could counter pick it. So it would be important for both players to pick an upgrade at the same time, or not know what the other person picked.
So what will happen is, you're gonna have kind of like a timer that runs, that players are seeing. They have to pick their selections before that timer runs out. And when the timer runs out, the clients are gonna automatically send their selections as a quantum command. You just have to make sure that internally in the simulation, there is a little bit of slack after that timer to allow that to, because you have no guarantees that the command is going to arrive within that tick that you predicted. It can arrive 1, 2, 3 ticks after, depends on the networking conditions, and commands are reliable. They're guaranteed to be delivered, but they may shift in tick if the network does not allow it to be delivered in time. That's different than the regular input that can be totally ignored by the server if it doesn't reach the server in time. So just give a bit of slack, but you have to send them here. And if somebody is very, very clever, they could actually write a tool that waits for that moment to see if the command from the other player arrived. But because you are receiving the command from the other player, full RTT, because the guy has to send it to the server has to send it to you. Maybe there is not even enough time for your client to wait for that and then send your. And it would have to be an automated tool that decides what to run yours, what to send as yours based on the other guys. So I don't think that is, a crazy guy could do it, but you have other ways to think about that. Based on, you would find a pattern that he always sends delayed. And I think that's an interesting idea. It's a turn-based game that you basically time the commands just with a bit of slack for protection. And you don't see what the other guy did until you guys do at the same time.
I think that probably works for a first implementation for sure. And then if you notice that maybe there's still a cheating problem, then maybe you can write some server-side code that makes sure these get delivered at the same time.
You can, you can do that. You can. That's actually, you're a clever guy, right? So I should have thought. I'm ashamed because I should have said that myself. Yes, you don't even need to run the simulation on the server to do that. So you can intercept a quantum command, you can decode the data in a quantum command and know what the data is, and you can hold those commands. Do not allow them to actually be confirmed into the simulation for a few frames until you get all of them. But so if your turns happen in if you have the simulation running on the server, yeah, you can do everything. But say you don't have, but your turns are in specific frame times. You can say, yeah, I'm expecting commands here for this before this frame. And what you do is you make sure you don't dispatch them until that frame arrives. So the guy sent 10 ticks before, 15 ticks before, but you hold them. And when that very frame is the time, then you inject them all together into that frame, and you don't accept anymore the frames for that, the comments for that round after that moment. So yeah, you can write server code to that if the game becomes successful. Then it's absolutely guaranteed that the commands are gonna arrive on the very, very same tick on every machine. And there is no way for the other guy to wait for your command to decide for his. No way. So yeah, you move to that safety layer again.
Yeah, well, that's really what I like about everything I hear about quantum is that the first implementation of everything is like so easy, and then it's like if I want to make this foolproof later, I can still do that later on.
In little steps, you can add these protection layers. Yeah, exactly. That's what I also like about it. Well, one of the things.
There's some one sort of silly question I have as well, which is like, I think there might even be some cases where I'd be interested in having a deterministic game simulation, but without even using your multiplayer. For example, for procedurally generation stuff, when I'm like, I always want the same seed to output the same terrain or something. Or maybe even for multiplayer games that use a different networking layer where I'm like, cool, there's this new kid on the block which is like space-time DB, and maybe I want to write an online multiplayer game with that. But I need a deterministic simulation to make it work, to make my auto battler work with the system or something. And I'm like,
do you really believe in that?
I don't know. It's just some.
I'm curious to see what happens. I mean, there are always these new players coming and going. So we don't try to solve everything, right? So we try to, as I told you before, we try to solve particular envelopes. I don't claim we can solve this or that problem, but I tend to recognize smart solutions that are interesting and that I have a certain skepticism on the costs. So there are some that are technically interesting as an exercise, but are questionable in terms of, okay, but how much does that cost? And we've had a few of these in the past, and they came and they went.
Got it.
And there are some that have questions about the technical solution feasibility or the scalability in general. And there are some that are really interesting and welcome as competitors, and that we hope sometimes they can convince people to use. There are examples in all of these, right? So I'm curious in this case to see.
Yeah, we will see. I mean, the question went off track a little bit, but I guess the question I had was more like, is there a chance for just the game engine part of Quantum to be available at some point without the networking attached to it? Because I even see, like, for example...
Short answer is no. Long answer is that you have to talk to us for specific use cases, right? So we've been asked this before. So a couple of notes on this. You can run Quantum when you run offline Quantum. I mean, you're building your multiplayer game with Quantum with a valid plan. You have an agreement with us and all that. But you also have a single player mode on the game. You have a split screen multiplayer that is offline split screen, because we also allow split screen 2 players on this machine against 1 player on that and 3 players on that. That is built in the solution. But let's say offline. When you're running offline, you're not connected to us. You as long as the game is part of a multiplayer game that uses Quantum, that's already expected, that's already allowed, that's within the terms, that is just fine. And you're not paying us when you're running anything, when you're running the local version. You are paying for the license, you're paying for everything with your online plan for the online part of the game. So that's already expected, and that's part of the legal agreement. We're giving this SDK that I have a 20 developer team of top-notch guys building, and our business model is the online plans. to run it completely offline without an online plan, that's not within the terms, even if you're building the game in Quantum itself. And so if you want to do something like that, you have to talk to us to see what is the exact case, to see if we open an exception for that. We are always open to talk. I mean, it might be possible, it might not be possible. Using the tooling really outside of Quantum is something that we've never done, that is not in the plans. But if you have an interesting case, then you can convince people about it. We are always open to talk, right? But each case is
I guess the point I was trying to make was also a little bit like, I'm kind of sad that there's no game engine that does what you're doing with Quantum out of the box, because I think determinism is highly undervalued. I really, really like determinism for all kinds of reasons, not just multiplayer. I think it's awesome that you can do replays easily. I think it's awesome that you can do basically deterministic procedural generation. I also really like turns out I also really like the ECS architecture that you use in Quantum.
You do
it's sort of a bit tricky to get into, but once you're in it,
you're gonna like it
very...
even more with the next version that we introduce stable components. They are even faster. So we have not only sparse set, now we are also table. So you can decide if you want sparse set or table per component. And when you filter table only, it's much faster to go through the entities, and all of our internal components are now table, like collide.
What are tables?
It's similar to archetypes. So an archetype is a composition of an entity, and it's stored on the same buffer. So instead of, it's ECS architecture, right? So there is a sparse set, which is, so a sparse set is ultra flexible, and the biggest point of it is that if you add remove components, it's a very cheap O1 operation for add remove. And get has, they are super cheap as well. On table components, has and get, they have the same performance as a sparse set, but the differences are, in a sparse set, add remove is super cheap. In table components, add and remove are more expensive, because you have to move the whole entity with all of its components to a different buffer if you add or remove one component. In sparse set, that is a one ends in cheap. But the filter, which is traversing a collection of entities that match a certain collection of components, is much cheaper in tables than it is in sparse set. So it is always a trade-off. Sparse set is normally more forgiving to developers, and that's what we chose Quantum to be designed with. Whereas tables can get more performance if you design things for it carefully and you know exactly what you're doing. You can get much better cache coherence and cache hits if you're very careful with your system design as well, when you benchmark everything. But you can achieve much more interesting performance level. So we're introducing that with Quantum 3.1. We decided, okay, it's time to do a hybrid ECS. Yeah, we do cool stuff. I mean, it's cool to work here. We have super cool guys. It's super fun to do. I in a certain way, I agree with you that it would be nice to have a lot more stuff that is open source, that does good things. But you can say the same about game engine in general. Like, so I love Unity, and I've used it since 2006 there, but it's important to have competition. Now you have Godot, and you may agree with some stuff, you don't agree with everything, but it is not yet there in terms of what you can get out of these engines. And even if you think about stuff like Unreal, I mean, Unreal is not a unanimous thing. I mean, it's visually impressive, but you have trade-offs, and yeah, you have source available, but it is what we live in the tech world, and there is some deterministic stuff around that you can rely on that is open source. But yeah, but nothing as complete as this. But I think it's, yeah, we don't have an open source game engine that is as complete with all the platforms, with all the stuff that's supported. So like Unity yet. With all consoles, with everything, with the facility Unity has. So
yeah. I mean, I wasn't even specifically talking about open source. I was just like, it's sad that there's no actual game engine with this specific profile of features,
built in the engine itself, like the engine is built on top of it. Well,
if someday somebody comes along and is like, I will build an engine on top of Quantum,
we thought about
make a visual interface for it, then
it's kind of like a pipe dream. So if a bigger player would come and say, hey, let's build a rendering engine on top of this, let's pump this gameplay engine to even another level of cleanup and organization and everything. Let's push this to the next level, including the runtime and a rendering engine. That would be an interesting bet, but would you want that as a game developer? Would you want to rely on you would be building, because this would restrict the types of games you build with this engine to these types of games, right?
It would be a specialized engine, but also one thing you have to remember is that a lot of games also aren't multiplayer. A lot of games are just single player.
And you could get replays, you could get all the benefits of determinism with that.
And also the dream of basically having a check mark in the engine that's just like, make this a multiplayer game.
Yeah, but that's what you get with. If you build with Quantum, you get that check.
Exactly.
Right?
Yeah, that's what I'm saying.
Yeah, it's something we think about. I mean, we kind of like dream about sometimes, but it's not a realistic dream, right? Yeah, so it is.
I think that's an answer I'm happy with. Like if it's on your radar, at least the idea.
It's an idea we're not crazy against. Okay. I mean, we're trying to integrate with other engines. We did do an experimental test with Godot back on the Unity. How can I call that? When they had the previous CEO bonkers business model switch thing that scared everybody. Yep. When that happened, basically to answer the community, people were asking a lot about it because Quantum is C#. It was agnostic to Unity as gameplay engine. So although Godot's C# integration is not nearly as good as their GDScript integration, but okay, let's see what we do here and let's share the results. And it wasn't interesting. We took one existing sample we had that was already implemented in Quantum, totally isolated. Let's run that in what we call the console runner, which is just a .NET version. And we have the Photon real-time transport layer that runs on C# without Unity. Let's load it with that. Let's run that from Godot. And let's port the view interpolation code to run in some Godot nodes and the entity view updater script to run as a Godot node. And let's see if we can export the gameplay scene. I mean, all the assets, the static colliders for the map, that was exported from the Unity sample because it was already ready as JSON, so we would load it on the C# simulation from there. But the visual, we could actually export the Unity scene in a format that was friendly to Godot. We just had to fix a few shaders and something. And then took 2 days and we got that running. And we did a very, very interesting test, which was a cross-engine deterministic playtest. So we were running the Unity build against the Godot build totally in sync without checksum errors. It was, we still have the video for that. But it was not practical to release it as a layer. We waited a lot to see how things would settle down, but that's still an open question. I mean, I was asked yesterday, what about a mono game layer for Quantum? And I said, I mean, guys, if you guys build a team that would be interested in doing that, we could help support this. We could get you guys in our premium program for free because you guys are doing something for a different engine. We're interested in that. So we would help you guys with support on this. And we would get the legal aspects checked to make sure this can happen. And yeah, we see this with very good eyes, of course. It's customers in the end. So we would like to have it. So that was my answer to the guys, right? We're actually now, because we have a new generation of Fusion being built as a native core for Unreal, that's been in tests by some customers already for Fusion for now. We also have a Quantum Unreal implementation, which is a totally new C++ implementation of Quantum, not ECS and so on. But that's a different story. But this Fusion core is also going to be integrated with different engines. I'm talking here Default, which already has an integration with Photon Real-Time, where there are a couple of other engines I may not be able to talk about because it's internal discussions still, but popular stuff. Not yet Godot, but that is on our roadmap. We want to try to integrate Fusion, this new core of Fusion that is native, to integrate it in Godot. And I would say I would actually be willing to integrate it with the script, not with the C. If the C# integration of Godot is production ready and is really good, yeah, absolutely. We all love C#. But so this is all in our roadmap, in stuff that we're interested in doing. We're not locked into one engine only. And
I see.
That's the closest to your question about let's build an engine on top of Quantum.
Okay. Yeah, let's shift gears a bit again. I guess there are a couple more game ideas that were floating around in our head, which I wanted to ask you about, which is like for more open world type games. Let's say like it's like a co-op game, it's a small party, it's like 4 players or something, and you are dropped into a very large, maybe procedurally generated world, and you kind of explore together, something like that. Would you tend to build something like that in Quantum, or would you tend to build something like that in Fusion?
It's a good question. It really depends a lot on what kind of systems you would need in this type of procedure generated world, and how much of it you need to be loaded in memory, how much of it you need. Because if you need to be a lot of it to be loaded in memory for the gameplay aspects of it, it means Quantum would have to have it loaded in every single client. If you go Fusion, then maybe only on the server, clients don't need to load everything. But then again, for players, your cost effectiveness, you're probably talking about one of the players being the server, a bit like Valheim does. But our normal answer will be Fusion, probably player-hosted client server would be the usual answer to a survival or open world type of game. The devil is in the details. It depends a lot on what type of procedure generation you're talking about. And I'm now, for example, working on a voxel-based collider check so you don't have to naively create triangles for the physics engine, because that's prohibitive. It becomes too big. But if you run directly against the voxels and your collision checks are proportionally the same size as the voxels, it is 0-1 for the checks. And so I'm running it's essentially Minecraft in Quantum, if you think about it. I'm doing a prototype with that. If it's that kind of open world procedure generation, maybe Quantum is interesting because you can load in memory only the chunks that are interesting now. But then you should think, okay, but can I unload one that is nobody's in that chunk anymore? Can I unload it from memory? But can I reconstruct it as it was? You always have to keep somewhere the data to. But it depends on what exactly is the type of procedure generation, what type of terrain, what type of modifications you do. But the normal answer would be Fusion, probably player hosted.
I see. So can Quantum deal with big open worlds if there are no? Is the question like how many movable objects are there in the world, for example? Like if I can, for example, reconstruct the position of all the trees from a seed, then I don't need to hold them in memory, right? I can just reconstruct that chunk when I get there again.
Yeah, that's so for example, the numerical representation accepts actually quite big range because it doesn't change. This is the one interesting thing about fixed points is that you don't degrade the accuracy as the number grow big. The accuracy is always the same. So the usable range is plus minus 32,000, which is pretty big. But the problem is how complex is updating these entities and how many of them you want to have. If you think about entities being loaded into quadrants, chunks, if you think about it, and there is not a single player in a certain quadrant, you could, for example, tag all the entities in that quadrant as non-enabled, so they would not be updated at all. They can still exist in memory. So it's a trade-off between how much memory is that and but you can actually make the update cost scale well if they do not even get into the filters, especially with the new version with table components, because that skips much quicker. So and so you don't need to think about rebuilding them. You can keep them in memory, and again, if we're planning to get the copy on write stuff, so because you're not modifying these entities, they're not also copied for the predictions at all, because their heap pages are not being modified. So it may be feasible to just leave them there. It depends, how many do you want? Do you want to have 2,000, 3,000 of these? Maybe this is not a big problem on a PC game. You can probably run a game like this at 30 hertz simulation. This always helps, because the rollbacks are going to always be less predictions, and the verified frames are also steady at 30 hertz. So you can always, the thing we're talking about, like running max 3 or maybe at 30 hertz on a PC, you can actually run max 2 verified frames per update, and that would be enough. If you've never been to a certain quadrant, you do not ever have to load the entities, the first version of the entities. You do not spawn them at all. And then you can think, and if it's really big, for example, even the ones you touched that were dormant, you are probably talking about at the end of the game, you want to save the game state as you was, and somehow reload it for the next playthrough as you was. Like, you want a persistent kind of thing. We do not solve persistence, right? So Netcode cannot solve persistence. So especially long-term persistence, because you add a new property. So our frame serialization does not survive with a new version the moment you add different data. But you would be custom persisting only the data you need, and then when loading again the game, you can actually pre-spawn the stuff you need on one of the clients, and then let the other players join the game, and they are going to receive that as a snapshot, and then they continue from there. Quantum supports that out of the box as well for late joining. So you could do that. So you can solve that. So you don't only spawn entities that a player, at least one player, ever went into that quadrant, and you don't load it again. And the ones that, and when we're reloading the game, one interesting way of doing it is you do not spawn the dormant entities on the next game instance unless somebody goes there again. But you load that into a database that everybody downloads, because they have the save of the game. It's kind of like assets for that. So there are solutions to scale that and still use quantum and have all the advantages of the predict rollback and the physics. But it's always challenging that. And the array modifications, the procedure generation, incredibly, this is the most challenging parts, because we built a lot of stuff based on Unity tooling, converting from the Unity editor into Quantum, and people struggle to implement the procedure generation themselves within creating triangles in our physics APIs and so on. So, but I guess that's kind of stuff you would not have a problem with.
Your physics API? Can you create triangles in your physics API?
Yes, you can use what we call dynamic map, and you can add, remove triangles. You can create one from scratch, or you can base it from an existing one. And I normally don't recommend it. It is well, maybe you would not have a problem with it, but some developers have a little bit of a struggle to understand. But yeah, it is possible.
Okay, it's good to know.
NavMesh is more of a problem, though. NavMesh is more complex. We're working on that to get, we have a port of Recast that can do deterministic baking, and that helps, but we're still working to get a new generation of the tooling for that to simplify procedure generation of NavMeshes. That's it, because it has to be deterministic. That's the big point, right? So we do have deterministic NavMesh, but deterministic generation we have partially. We can convert the data deterministically to our format, but the full generation, we haven't covered yet everything, but we're working on that.
Okay. And for, I guess, the fusion approach to do procedural generation would be to do all of the generation maybe on a server and just share it with all of the clients.
If you're thinking about like a static collider for the terrain, big terrain or something like that, if you have a deterministic generation for that on Unity in general, you can actually just sync the seed from the server and do it on every client. That would not be a problem. But it's all about, like, do you want it to be modifiable? That is where the challenges start in both cases, right? But generating is generally possible.
And then, for example, if I do procedural generation in quantum, that's maybe also one of those cases that's a bit more expensive. So I would maybe also try to only do that on confirmed frames, and maybe also
to generate the stuff, there are multiple options here. So if you're talking about like the initial version of the game for a new world, you're creating a new realm, Minecraft or Dwarf Fortress style. So you can run that on one machine. Then it does not even have to be deterministic, as long as the late joining data becomes deterministic. The stored data is deterministic. So, or you can actually run with the same seed deterministically on every machine before they start the quantum simulation, even if they're going to late join to receive the mutable part of the game state from the guy that's already running, but the bigger chunk of a static asset that is the world, that they can generate before starting quantum. So that doesn't affect simulation performance. You just run it before in these two cases. And then, but you can also run the procedural generation from within the simulation itself, but then it would going to impact simulation performance, and you have to be careful with it, with how much we're doing from there. So it depends on how much it is.
Yeah, I guess it depends also on the kind of game a bit, right?
Yeah, sure.
If maybe you have a fixed size island that you just generate at the beginning, or if you have like an endless train track that you want to keep generating as you go or something.
Yeah.
Different problems to solve, yeah. I see.
But when you can generate incrementally, you normally can get along with generating within the simulation, because you can do in smaller chunks, and so you make sure your performance envelope fits.
Where do you think are all of the game engines at with their multiplayer implementations? Because I'm always like, the first game engine that's gonna crack multiplayer will have such a huge advantage. But so far, it seems like everybody's like...
Source Engine has good multiplayer. Unreal has a functional object synchronization layer that's very reliable. It's a bit legacy, but it's very reliable. It's on that mid layer, and they have a proper client-side prediction for the character and for game ability system, and that's where they are. They don't have an offering in Determinism. They don't have an offering in client authority variation. Unreal. Unity, they have the object synchronization layer netcode for game objects that has both client server and client authoritative, but their client authoritative version doesn't have the middleman stuff capabilities we have. And their client server doesn't have like compensation, timing information, and they've been improving on that, but they're trying to get from an object synchronization layer to a bare netcode. I don't know what's the current state of it. I honestly don't pay too much attention to that. And they have their ECS netcode, which is built on top of good principles. It's some trade-offs. Their ECS is still not really mainstream, and I don't know if that's gonna ever be really popular, or if they're gonna crack what they've been announcing of making the game object world be backed by ECS. That would be interesting to see. But in any case, they're doing that is pure client server only for now. And if you see their demos, they do 10-player, maybe they've never shown a demo with, we do 200 diffusion, but it is built in good principles. I know they're great guys, so they good developers. I'm not saying that they cannot crack it. They're capable, they're excellent developers. It's that they have their goals, they have different targets, they have different milestones, and they're getting their things. But we're still competitive, we're still doing, and we have a very good relationship with them as well. So, but that's how I see them. Maybe some other guys from our team would have more details than I have on the technical implementation of these ones, but more or less that's how I would tell they are now. Other engines don't have a netcode solution at all, so they're purely single player engines.
I mean, it's obviously a way to make some reoccurring revenue for them. So I think game engines generally are are keen on getting this to work somehow, right? You can keep developers in your ecosystem, and then
Yeah, but I think they overestimate how much of a market that is. We are successful. We're a profitable company, but I would say we're small but we're a very lean 60 people company, right?
Yeah.
And we have an interesting portion of the indie market and the mobile market. It's not huge, not crazy, but we do power important games, and we have a sustainable, profitable model. But compared to what the size of Unity as a company and what they need in terms of, I think we're not the revenue, even if they would get the same size as us in terms of business, I don't think that would move much of a needle for them. So maybe they overestimate this. I don't know.
Well, for what it's worth, I think the reason why not more developers are making multiplayer games is because it's so difficult. So if at some point somebody figures out how to make it easy, I think we will have a lot more multiplayer games. I think almost everything will be multiplayer if it's easy enough.
We're trying to. I believe it is possible to make it easier. I'm not sure I agree with what I see out there. I'm not talking about Unity in this case, but I see other people trying some stuff. I'm not sure I agree that, especially when you try to make it easier but make it extremely more costly, that for me doesn't work in today's world.
Sure.
Where we need to be lean, we need to keep wasting less energy, less resources in general, even for the world itself, but also as business models to stay competitive. So, but certainly that's a goal, to make it as easy as possible. Sometimes the easy is you need to do 2 steps up, but then it becomes flat. That's certainly what we try with Quantum, but it's a couple of big steps. But I like that idea of making it easier. It's definitely number one goal, making it easier without compromising performance and costs. That's the
right.
Summary.
Cost is obviously also a big one, so maybe we can get into that really quick. I think you have a free tier, right? And you charge based on concurrent users for all of your solutions.
Yes. For all running online, it's always based on concurrent. Running local single player version of split screen, it's not connected, so it doesn't count.
Right. That is free, but only if you intend to use the multiplayer part as well. Otherwise.
Yeah. And we have SDKs are free to download and use for development. You can create app IDs for development. To release a game with, you need at least the 100 CCU free, which is, so 100 CCU may not sound a lot, but we were talking about this before. This is kind of like you have 2,000 players playing the game daily. That's what you get with 100 CCU. This is like you sold 50,000 copies of the game. 100 CCU is gonna get you with that, and that's totally free. You just keep renewing it. It will never. We don't plan to make it. We've never made things. We only made it easier. So we added this 100 CCU free. We didn't have it before, and so on. So then the next layer is still subsidized. So if you get the 100 CCU, because this is for only one app ID for your account. The next one is that if you want to have that for multiple ones, you can pay the 100 CCU version to have it in multiple app IDs. That is per year 95. That is totally subsidized. That doesn't cover the costs. It's really okay. The other tiers are, especially the higher ones, pay for it. But we've never had anybody who gets to the paid tiers asking or saying that this is expensive. Because when you get to need a 500 or 1,000 CCU, you were making so much revenue when you got there that you realize that the costs of our stuff is like 1% less, and you are paying 30% to Steam, and you think they're relays for free? Well, you're already paying for it at 30%, right?
I'm already paying for it, so I might as well use it.
But if you want to get
sunk cost
Switch and other, you don't get it, right? But well, we already talked about this. But the point is that it is cost effective, and this is the model we have. It's proven to be fair. You have all these. Ask the guys from Landfall. Peak is not their first game with us; it's the third, all successful. So they keep running with us because they trust us and they know that the cost is totally fine with what they do. Repo, it was the first one for them, but they're already thinking, oh, we have to do more stuff. They're incredibly happy as well.
Yep.
Phasmophobia
awesome.
And all these guys. And
so I guess one of the fears you have as a developer is always, because for single player games, it's very nice. It's kind of set it and forget it, right? You upload it, and once you fix all of the major bugs, it's kind of like you can leave it alone for a long time without having to touch anything. So I guess one of the worries you might almost have is that your game becomes too successful, but it's like a one-time purchase kind of game, and people just keep playing it, and causing very long tail of server costs. But this is not something you've seen in practice.
Normally, when this long tail style of thing, even for games that people do not monetize, you are not gonna get thousands CU. I mean, if you don't touch the game anymore, normally keeping the 100 CU thing is enough. And I mean, even if you have to pay for the 500 CU, that's gonna cost you how much in 10 years? It's really, you can plan in advance to, we're gonna fall down to this. If we get down to this, it's gonna be this layer for 10 years or for 15 years. You definitely will have stuff.
To be fair, if you have 500 CCU over a longer period of time, then your game's probably still doing okay. So,
or your probably still selling some copies that would definitely pay for that. But you may also be building other games that are selling and keeping your old game alive with a decent 500 CCU is a lot. Check SteamDB. Try to find which games are at 500, right? So
that is a lot,
so say you're doing another game. So keep funding your old game with the revenue for the new one is a very, very good message to your community that you still care, that you still support them. You're not updating the game anymore except for a critical bug fix or something like that, but you are still paying for the infrastructure for the game to run. And so this, if you do not have some people actually keep doing DLCs that you do not have to pay for it again, because if you already paid for the game, you get the DLC for free, right? But this normally stimulates new people to buy a copy of the game. So normally it's a good way to do. It's not really a live service kind of thing because you're not asking people to pay recurrently multiple times, right? So it's just that, you buy your copy. But there are many ways to keep this afloat, either with and again, it's never been a problem that. But do you want to discuss about game conservation aspects of this? Because you mentioned that.
That is also interesting, because it's also like you want your game to be around 20 years from now, and I feel it requires a lot of trust to think that like every company that provides online gaming solutions, for example, is going to be around in 20 years. I think a lot of them will probably not.
We've been around for 22 now, but so we've seen many come and go, but the but is a positive one. So it's a topic I care a lot about personally. And occasionally we get companies asking about that. What happens if you guys go out of business? We have some signed stuff about if we sell or if you do something. I'm not familiar with these things, but we do have some very, very big companies. So we've talked a lot about indies, right? But we have big publishers like Ubisoft, Facebook, Meta, some I cannot talk about. These guys all have agreements signed with us. They use our stuff for many things. And some of them have but in contract some stuff about what happens if this happens and this and that. But let me just talk about practical stuff that matter for the solo developer and everything. So we've discussed internally, and we're one thing we want to do. We want to make sure that if you're running fully online and you're running with Netch punch through, you're using our cloud services and all that. For that, you have to have an active plan. But you know that if you're running offline single player, you're not paying anything. It's if you turn off the servers and because your studio is out of business, but the single player is still gonna keep working. We don't have any type of pinging to validate the license of the local game. That will never happen. But more than that, we've discussed internally a lot, and we're trying to see if we can make, especially for Fusion player hosted, to make LAN only games work without the cloud. So if we can reliably guarantee that you're not using this as a loophole for something, we have to be careful, right? So
yeah.
But internally, we would like we everybody from CTO to us engineers and everybody, we want to do this, and we're trying to solve any legal aspect that exists and everything to try to make it possible. And so we want to offer this, which is okay. People ask a lot about this, although nobody plays LAN anymore directly, but it would be a way to keep the multiplayer alive. Even if we go out of business and the studio go out of business, you would still have the LAN variation working. So I cannot promise because this is not written in paper, but I'm telling you, it's a topic I care a lot about, and we do care about all these developers who think about this, and it doesn't hurt on the business model perspective to allow LAN only to be done without pinging backends or anything.
Mm-hmm.
I cannot guarantee that the other stuff you use will do the same, but we're trying to. So we try to be. I assure you that the local single player variation doesn't touch anything. You can check the code, you can monitor the activity, just unplug the stuff. It works normally. It will never stop working. And we're trying to get this also for Fusion on LAN. For Quantum, it's a little bit harder because the server side, the coordination piece, we only have it existing on the server. It doesn't exist on the actual client. So it's a little bit harder to get it there. But we do have deals, for example, for people who run a local instance of a Photon server say you're developing your game and you're going to do it with Quantum. You want to go to PAX East to show your game, or you want to go to Gamescom. Let's go to Culling. And you are not going to trust to run on our infrastructure with the Wi-Fi from the conference, right? So you want to have a local setup. Can you do that? Yes. You talk to us. We're going to give you a local license for a Photon server with a Quantum plugin that you can run locally for the conference. It's going to expire in that case, but we solve it for you. So all your game is a special thing that runs on an attraction. It's like on theme parks or something like that. We can discuss a solution for it to run offline in that case as well. It doesn't solve the game's conservation aspects yet, although for the LAN variation would be interesting for that. But yeah, we do care about these cases. We were always open to talk, and I personally am enthusiast of that. I think games should be always possible to conserve. And I wish every tool you use would think it the same way and would be open to, or at least work towards solving this in the near future. But yeah, it's an interesting thing.
Yeah, I guess we game developers are also sometimes a bit hypocritical about it. We want the tools to do the work for us, and then we ourselves often don't put in too much effort to make our games conservable ourselves. So there's also that aspect.
That's an interesting aspect, because you asked if the tool is, but you have to be careful because you also have to do some work to make sure your game will keep working. Yeah, it is. You have player backends, and
that's right. I guess interestingly, one of the best guarantees you can give is that your business model works, right? If you're like, this is making us money, then I trust that you're not gonna shut down the servers. So
yeah, we're not a startup. We're privately owned.
Yeah,
we've been initially based on investment, but that was solved a long time ago when the company was reacquired by the founders. And we've been running a profitable model. We're safe financially. We invest profits back into new products, into the company. We hire very good people all the time. So I was interviewing more guys this morning. And
Nice.
so yeah, we're good. And we will try to keep that way for much longer.
I guess that makes sense, right? Because if, like, my reasoning is just like, if the servers are profitable, why would you shut them down? Like, the first thing you do would be to stop developing new products, and I don't see that either. Sounds like you're still cooking.
We just released Fusion 2.1 nightly builds for Circle, which is the premium support program. So subscribers of that, they are seeing now nightly builds of the new Fusion. The new Quantum 3.1, we're about to release the nightlies. Fusion Unreal and Quantum Unreal are in beta for Circle subscribers. We're planning to release Quantum Unreal publicly as an MVP beta still this year. And I'm already thinking about Quantum 4 and what should we put into it and other engines. So yeah, we're in constant active developments. We have stuff being ported, rewritten in Rust, some old C++ code base we have. So we can even afford to do that, which is to get some older stuff we have to be refactored, to be modernized. And we're always doing that. So, and we're always happy to talk about and show what we've been doing. You just saw a little tip of the iceberg by talking here.
What advice would you have for people who are building their first multiplayer game? Do you see any common pitfalls that a lot of developers tap into?
I think the most common pitfall is the same in general as game, is that you get too big of a scope. So you go for that and you try to build your dream game the first time. And I would advise you to take a more relaxed approach in that. Build much simpler stuff first, release much simpler stuff first, try out different things. If you're thinking about our stuff, learn Quantum. Even if you do something that fits really well with Quantum, learn it, apply it on a game jam or something like that. See what you do with it, prototype a lot. Then learn also Fusion. When you learn Fusion, you also learn a lot of other SDKs which are similar in principles. And then you're going to learn. It's like when programming, if you think about one paradigm only, you are a bit of restricted. If you learn how to program functional, then you have procedural with separation of code and data, and then you have object orientation, which is kind of like villain at the moment. But when you see multiple paradigms, it opens up your mind to grokking programming in general better. The same is multiplayer. The more you learn, the more you understand and you know what to use for each case. So start small. That's the main advice. Try something very, very simple. And don't try to say, oh yeah, I'm going to build a fighting game because that's simple. Fighting game is ultra complex because of the timings involved, and it has some very specific patterns in it that it's a crazy community that is fanatic. And so start with something simple, and then try to multiplayer it in different ways. See what the challenges are. Do not go for your first as your dream game as the first one. That's the first advice.
Cool, makes sense.
Yeah, and prototype.
Yeah. What is the correct way to prototype a multiplayer game? Because you have a lot of. Usually, the idea of prototyping is you try out your ideas very, very quickly so that you see if they make sense or not. And multiplayer sort of stands in the way of that because it's something that slows you down and that requires you to do some upfront tech investment, basically. So it's almost like you got to know what you're gonna build before you build it with multiplayer. Do you have any experience with prototyping multiplayer games, and what do you think?
That's what I do every
reasonable?
Day, all the time.
Okay.
And I mean, I'm spoiled because I like to prototype with Quantum. And because I am so proficient with Quantum and so efficient in Quantum, I don't prototype more slowly because of I'm doing multiplayer. I just do it with Quantum, and you know that when you program in Quantum, you don't think about networking, you just think about gameplay. And because I prototype as fast in Quantum as I would do in pure Unity, I don't get any slowdown because it's multiplayer at all. But this is specific to the kind of stuff that Quantums work better. If you're doing Fusion, I would say the best way to prototype and not get things too quick. Oh, sorry. Do not slow down too much is prototyping shared mode. Don't be afraid to use shared mode. Client server is a lot more investment in terms of prediction and all that. Don't worry about cheating if you're just prototyping. I mean, if you're doing in Quantum, the prototype can even become production ready because it's not going to change the way you do it. But if you're doing Quantum client authoritative shared mode, maybe you were going to do in the end as player hosted. As you get more proficient with it, you may get as efficient in client host in client server as you are in shared mode. But I would say coming as a Unity developer, shared mode is the easiest one for you to think about. You invest a few days learning the tool and then you start prototyping with it. Then it doesn't really add much of a time. Here's the devil on the details. So prototyping small things with state replication does not add a lot of complexity to it if you do it carefully and you understand, for example, a tool like Fusion or another SDK works. But that is the deception, because state replication, because the replication is there showing in your face as a developer when you're building your gameplay. As your game complexity grows, as your prototyping is becoming the production version of the game, the complexity also grows with it, and it becomes, if you're not very careful, the complexity becomes unmanageable. So prototyping is not the problem on multiplayer. Going into production and maintaining it as sane is. And that is what Quantum does not suffer much from if you're careful. Of course, there are exceptions. You can mess it up. But normally, because it's the same as a single player from the perspective of the simulation code, the complexity grows with the game complexity, but let's say it's a more linear relation, whereas in state replication in general, it is quadratic or exponential with the complexity of the gameplay. Prototyping is never big deal, but again, in both cases, you would have an initial learning curve. But once you get there, I think the best answer to prototype multiplayer is that you need to start. Once you start thinking multiplayer, you will always think multiplayer, and you start thinking about single player as the byproduct. And then it comes naturally to you.
So you would say prototyping multiplayer does not slow you down that much once you're familiar with the tools, whether you use Quantum or Fusion,
it slows down less in Quantum. It slows down a bit in Fusion, but it's not as bad as people think. It gets slower as you get more complexity. And this is not specific to our tooling, right? So in state replication in general, it grows in complexity. But what is more complex in multiplayer always is the game design and the gameplay implementation, right? So forget for a moment online multiplayer and our tooling. So think about a split screen game or even a single screen game, but you have multiple players, multiple player inputs, and you're planning that game, implementing that. That's different. You have to think differently. But if you think about the game as a local multiplayer game, well, for Quantum, that's already what you do. You think about it as a local multiplayer game, and that's it. That's all you need. In Fusion for prototyping, you have a little bit added stuff here and there, but it's not crazy. It automates a lot of stuff for you, and you can still treat the local input in Unity directly to move the character and all that for client authority shared mode that I suggest you should prototype with, because it's easier to start from. And because it's also cost effective is the choice. If you need to go state replication, it's the recommendation we have, for example, for a mobile game. PC game is more forgiving. You have the full choice. All 4 options are valid, so you really go for the one that makes more sense. But I think the answer is more on that you have to think multiplayer from day one when prototyping, regardless of online multiplayer. But multiplayer, start thinking about that every day, and then it becomes second nature.
As someone who mostly builds the tech, do you sometimes spend a thought on what makes for a successful multiplayer game?
I do. SteamDB is my friend. I watch SteamDB every day. I mean, I scroll through and analyze the stuff every day. I prototype a lot. We're all game developers, right? So we all come to this because we like developing games. I've been a game developer in indie. I founded my own studio many years ago. I ended up not successful as many of us do, and I landed an opportunity here and to never look back. But I like to think that I actually am part of some of the teams that ship the stuff with us. It's a different type of thrill, it's a different type of work, but we work together with a lot of our customers. So we do workshops with them, and I get to play test games before everybody. We see things, we know what's coming. We get as excited as the team because we see it's our tech, it's our code going there as well, the same way. But and I still do prototype a lot, but there is a practical reason for that. So I like to analyze trends, to see what's happening. That's why I watch your channel. That's why I watch many other channels.
Okay.
I like to understand what's going on and what's the stuff that's prominent, what's working with players, what's resonating at the moment, because we have to make sure that we build features, that sometimes we create a sample or we create an add-on, which is a helper set of libraries that fits a certain genre and that developers want to do now. We don't do games. We never compete with our customers ourselves. But we like the tooling is not only the netcode. So Quantum is a game engine. We have to build so much stuff on top of it to help people build stuff with it. Animation curves, splines, stuff, and a lot of these Friends Lop style games kind of, and also the frustration with trying to do full predict rollback physics with PhysX that doesn't scale for that. Led us to develop a different way of predicting physics. We name it Forecast, that comes with the new Fusion SDK. We already have some very positive feedback on our public Discord that you can see. So that was because of this genre, and it's not gonna work for everything. It's not gonna solve magically. It's not gonna replace full prediction and rollback like Quantum can do for physics. That's much more accurate and better. But we cannot do that with PhysX at all. It doesn't scale. So this is interesting because it solves these more simple genres, carrying stuff around, pushing stuff around, and incredibly, it works really well for car physics, which may sound as a surprise, but if you do it right, it's actually very good with that.
Nice.
But I look at trends all the time. So, and I'm constantly prototyping stuff, mashing up between two different things.
Do you think in what succeeds or not? Do you think it in trends, or do you think it in more like design choices, or what do you think what makes for a successful multiplayer game? Is it hopping on the correct trend at the correct time, or is it something else?
No, it's when you make the trend.
When you make the trend, or if you write the trend.
I was thinking riding the wave at the same time. So yeah. If you're behind, if you're trying to mimic a trend, you may have lost already the wave.
Yeah.
You need a bit of luck. It's a mix between capabilities, your qualities as a game designer and developer to execute, and a bit of luck. But maybe this is a question you should ask to the Landfall guys. They are so good. They landed 3 hits in sequence. How many times you've seen that happening?
Yeah. I mean,
which
what
is
they do,
the sticky game, totally accurate battle simulator, then content warning, and now peak with collaborating with Crab. So I forgot the name of the other studio.
Yeah, they have a crazy success rate.
But they're riding the trend, and
they're riding the trend and creating the trend.
Yeah. So that's what but it's fun to talk about it after it happens. But what is next? I don't know. I wish I did. but
I see.
I don't.
So you do think you need a little bit of foresight to maybe anticipate these waves?
You need
or to make something so good that you create the wave.
I would like to believe these guys are. I know some of them. I talk to. They're in our support channels and everything, but I do not work directly with some of them. But I see from other studios I've worked with that you need to be creative. You need to be smart. These guys are smart, and they're smart, creative, and they're competent in executing stuff, and they're incredibly passionate about what they do. But is that enough? No, there is some other magic recipe plus a bit of luck. Oh, a lot. I don't know. But yeah, I wish I knew the answer. I try to. We sometimes we try to anticipate some stuff, and we occasionally we prototype something that's unique, that it's not same as before, or worst case sometimes we do. I mean, we see something that is PC only, and we know that these guys are not going to do that in mobile because the way they did would not port to mobile, and then we may create a sample for a customer that is similar in some ways, and then the customer is responsible for doing it, but it's not the rule. But I personally occasionally create some prototypes based on okay, what if we mesh this and that and see what. There is this new trend going now on PC games in this direction. What if we get this trend but twist it a bit and adapt it to this? What would become the game? Then I like to prototype this, and then if it's fun when we play test, we may share it with customers to see if they do. We may share with the studios building the games that inspired us to do, to see if they would like to have a spin-off that is different. But this is just prototyping. I mean, I'm both a tools programmer, engine programmer, and a gameplay systems programmer. I like to think that I am very good at, if a game designer describes me something, or if I see something as a mock-up or something, I am very good at implementing that as a proper interactable gameplay. So that's something I can do well and quick. So that's why I prototype so much.
The reason why you prototype is to figure out how to make your tools better?
To eat your own dog food. I occasionally I find bugs that, because I'm using it slightly different than the usual developer, and then I find a case that was not checked, and then it's giving me an inconsistent result, and then I report it to the guys. Sometimes I fix it myself if it's part of the code I originally built. But yeah, it is constantly to be testing the limits to see how our tool can be used, and to both exercise how to do that to show to customers, and know how to answer, and know how to give them suggestions, to know how to give you a suggestion on how to implement this or that, but also to find bugs. I mean, it's not only me. I mean, everybody in the team, they're all game developers, so they all take some time of their work to prototype. And we have a channel in our internal Slack called Work in Progress and Playtest. That's essentially for us to share our internal prototypes that we're working on. We can spend some time, normal work time, on these, and then we always share and we have playtests together on these fun things. And yeah, we do this. All of us do this, and I think it's a very healthy thing to do, because we're constantly using our own tool to build the kind of stuff we like. I think it does help. I don't know how much it shows, but we do this a lot.
Now that you say it, I think it shows a lot, actually. Because you don't want the actual developers using your tools to find all of the bugs and report them to you.
We're not ashamed when they do. I mean, they find,
but
and if it's a bug, we fix it. But definitely we want to improve, and there is no better way, and we have fun doing it, so why not?
I think that sounds extremely healthy. That's really cool.
Are you based in Germany as well, or?
I'm based in Germany as well, yeah.
Do you go to Gamescom and other conferences normally?
Normally not, but I might go next year.
Okay, interesting.
Also, I think I met one of your colleagues at...
was it Robert?
At the port side.
Or the...
Games Assembly. Could be, yeah.
Oh, Games Assembly. I think it was Robert or the Mark, maybe. One of these two, yeah. Cool. I mean, one thing we occasionally do, I mean, if you are not too far from Hamburg, you are also welcome to come to visit our headquarters. It's here in the Hafen city, so just
Nice.
feel free to touch base on that. It's we like to get people here and to visit us. We're
cool. Yeah, I mean, Paul and I will probably reach out once we start making our next game. Once we know what we want to build, we'll probably reach out again and try to get some advice from you guys.
Yeah, would be happy to.
Cool. Yeah, I mean, that's it from my side for now. Do you have anything else?
No, I mean, it's just, it was super chill, super fun for me. And I just want to thank you for the invitation to chat with you about multiplayer. I hope these were interesting topics for you. And I hope it was not everything obvious and it was really some useful stuff for you as a developer and also for your audience. So, as I told you before, I already follow your channel and I knew you from the videos before. So it was a nice surprise when you first reached out to ask questions about our stuff. So we're happy you did. So
yeah, I mean, thanks a lot for taking the time. Yeah, I was kind of asking some boilerplate questions for the first hour there, I think, or so, but like the last 2 hours were all like just stuff I've been very, very interested in, and I definitely got some cool answers. And
yeah, you see, I like to talk a lot. So yeah, even
That's
if you ask some boilerplate stuff, I like to talk about it. So maybe that works.